using substitution and elimination to solve problems. To use substitution to solve a system of two linear equations, 1. Isolate a variable on one side of either equation. 2. Substitute the expression for the variable found in step 1 into the other equation. 3. Solve the equation in one variable found in step 2. 4. Substitute the solution found in step 3 into one of the original equations and solve for the other variable. In this example, we want to solve the system by substitution. 4x plus 3y equals negative 14. Y equals 2x minus 8. This system is set up perfectly for substitution because our second equation has y equals 2x minus 8. Substitution works best when you have one of your equations in an x equals or y equals format. So my first step is to take the 4x plus 3y equals negative 14 equation and replace the y with what y equals. So we have 4x plus 3 parentheses 2x minus 8 equals negative 14. Bring down your 4x, distribute your 3, so I have 6x minus 24 equals negative 14. Adding like terms, 10x minus 24 equals negative 14. Add 24 to both sides. 10x equals 10. Divide both sides by 10, and x equals 1. Now to find y. Since y equals 2x minus 8, y equals 2 times 1 minus 8. Since 2 times 1 is 2, 2 minus 8 gives us negative 6. Our answer is 1, negative 6. It's always a good idea to check your work. So for my first equation, 4x plus 3y equals negative 14, I'm going to replace x with 1 and y with negative 6. So I have 4 times 1 plus 3 times negative 6. 4 times 1 is 4. 3 times negative 6 is negative 18. 4 plus a negative 18 is negative 14, which equals negative 14. So it works for the first equation. For y equals 2x minus 8, replacing my y with negative 6 and my x with 1, I have negative 6 equals 2 times 1 minus 8, which means negative 6 equals 2 times 1 is 2, and 2 minus 8 is negative 6. So it works for the second equation as well. In this example, we want to solve the system by substitution. 4x plus y equals negative 10. 7x plus 3y equals negative 15. Since I'm using substitution, I need to pick one of my equations and solve for either x or y. I can do this with the 4x, the y, the 7x, or the 3y. If I were to take the first equation, 4x plus y equals negative 10, and solve it for x, I would subtract y from both sides. So 4x minus y equals negative 10. Then divide everything by 4. So x equals negative 1/4 y minus 10 over 4 reduces to 5 over 2. Now, if you don't want to work with fractions, solving the first equation for x would be a bad idea. We can always avoid fractions by looking for a 1x or a 1y. Using the 4x plus y equals negative 10. This time I'm going to solve for y. Y equals negative 4x minus 10. I have y by itself and I don't have any fractions. So if I don't have x equals or y equals to begin with, I need to look for a 1x or a 1y and then choose that equation and solve it for x or y. So now we're ready to substitute into the second equation. 7x plus 3 times negative 4x minus 10 equals negative 15. Distributing, I have 7x plus negative 12x minus 30 equals negative 15. Adding my like terms, negative 5x minus 30 equals negative 15. Adding 30 to both sides, negative 5x equals negative 15. Dividing both sides by negative 5, x equals 3. I can use my y equals equation now to find y. So y equals negative 4 times 3 minus 10. Negative 4 times 3 is negative 12. And negative 12 minus 10 is negative 22. So we have 3 negative 22. We need to check. Starting with 7x plus 3y equals 15. 7 times 3 plus 3 times negative 22 should equal negative 15. 7 times 3 is 21. 3 times negative 22 is negative 66 equals negative 15. 21 plus a negative 66 is negative 45. And this is not a true statement, so there's something wrong with our answer. So going back to our work, we have 7x plus 3 times negative 4x minus 10 equals negative 15. So 7x plus 3 times negative 4 is negative 12. 3 times negative 10 is negative 30 equals a negative 15. 7 minus 12 is negative 5, so negative 5x is correct, minus 30 equals a negative 15. Then we added 30 to both sides. So I should have had a positive 15, which would have given me a negative 3 for my answer. So that's where my mistake was. Checking your order pair into the original equations will help you find an error. So y is supposed to equal negative 4 times negative 3 minus 10. Negative 4 times 3 is a positive 12. And 12 minus 10 gives us 2. So the correct order pair is negative 3, 2. So checking again in our second equation, 7 times negative 3 plus 3 times 2 is supposed to equal negative 15, which gives us a negative 21 plus 6 equals negative 15, and negative 21 plus 6 is negative 15. So far so good. 4 times x, which is negative 3, plus y, which is 2, equals negative 10. 4 times negative 3 is negative 12, plus 2 should equal negative 10, and negative 12 plus 2 is negative 10. So now we have the correct answer. Using elimination to solve a linear system. To use elimination to solve a system of two linear equations, 1, if needed, multiply both sides of one equation by a number, and if necessary, multiply both sides of the other equation by another number to get the coefficients of one variable to be equal in absolute value and opposite sign. This means we want the same number but different signs in front of x or in front of y. 2. Add the left sides and add the right sides of the equations to eliminate one of the variables. 3. Solve the equation in one variable found in step 2. 4. Substitute the solution found in step 3 into one of the original equations and solve for the other variable. In this example, we want to solve the system by elimination. 3x minus 5y equals 26, and negative 3x minus 2y equals 2. So the first thing I want to do is add up the two equations. 3x minus 3x gives me 0x. Negative 5y plus negative 2y gives me a negative 7y. 26 plus 2 gives me 28. 0 times x is just 0. Which means I have negative 7y equals 28. This is how elimination works. With elimination, if I have the same number but different signs in front of my x, when I add them together, the x will disappear because they add to be 0, and 0 times x is 0. So when we're doing elimination, you always want the same number, so they both have a 3. One's a positive 3 and one's a negative 3. So if it's not present in the original equation, then we need to do something to create that. Back to our work, dividing both sides by negative 7, y equals negative 4. Then choosing one of the original equations, like 3x minus 5y equals 26, I substitute, so 3x minus 5 times y, which is now negative 4, equals 26, and solve for x. So 3x plus 20 equals 26. Subtract 20 from both sides. 3x equals 6. Divide by 3, and x is 2. So our answer should be 2, negative 4. To check, I'm going to start with my bottom equation, negative 3x minus 2y equals 2. So that gives us negative 3 times 2 minus 2 times negative 4 equals 2. Negative 3 times 2 is negative 6. Negative 2 times negative 4 is plus 8. And that does equal 2. Using 3x minus 5y equals 26. 3 times 2 minus 5 times negative 4 should equal 26. 3 times 2 is 6. Negative 5 times negative 4 is 20. So 26 does equal 26. 2, negative 4 is my correct answer. Solve the system by elimination. In this example, we have 2x plus y equals 2 and 5x minus 2y equals negative 13. So here, if I were to just add my equations, 2 plus 5 is 7, and y minus 2y would give us negative y. So that's not really helpful. What we're looking for is the same number but different signs. The smallest number that 2 and 5 go into evenly is 10. So one option is to have a positive 10 and a negative 10. For my y's, the smallest number that 1 and 2 go into evenly is 2. So I need a 2y and a negative 2y. It's going to be a little easier to get the y's to be the same number. If I multiply my top equation by 2, that means I would have 2 times 2x plus 2 times y equals 2 times 2, which would give us 4x plus 2y equals 4. Using 4x plus 2y equals 4 and 5x minus 2y equals negative 13. If I add them up, I'll have 9x equals negative 9. By multiplying my top equation by 2, I ended up with the same number but different signs for my y, which eliminated y. Now I can divide both sides by 9, x equals -1. To find y, I want to go back to one of my original equations, just because the numbers will be smaller. So I'm going to use my 2x plus y equals 2. So 2 times -1 plus y equals 2. -2 plus y is equal to 2. Add 2 to both sides, and y equals 4. So my answer should be -1, 4. Now we're ready to check. So starting with 2x plus y equals 2. 2 times -1 plus 4 should equal 2. 2 times -1 is -2, plus 4 equals 2, which means 2 equals 2. Using 5x minus 2y equals -13, substituting into my equation, I have 5 times -1 minus 2 times 4 equals -13. This gives me -5 minus 8 equals -13. So -13 equals -13. I do have the correct answer in -1, 4. Solving inconsistent and dependent systems. Inconsistent system of two equations. If the result of applying substitution or elimination to a linear system of two equations is a false statement, the system is inconsistent. That is, the solution is the empty set. This example, we want to solve the system y equals 3x plus 1 and y equals 3x minus 9. Because both my equations are y equals, I can use substitution. So I'm going to substitute 3x plus 1 into my second equation for y. So the result's going to be 3x plus 1 equals 3x minus 9. So to solve it for x, I need to get them on the same side. So I'm going to subtract 3x from both sides. What happens is my result is 1 equals -9. And this is a false statement. The system is inconsistent and the solution set is the empty set. Dependent system of two linear equations. If the result of applying substitution or elimination to a linear system of two equations is a true statement, one that can be put into the form A equals A, then the system is dependent. That is, the solution is the set of ordered pairs represented by every point on the same line. In this example, we're going to solve the system y equals 5x minus 2 and 10x minus 2y equals 4. Because my top equation is in the y equals format, I'm going to use substitution and use 5x minus 2 to replace y in my second equation. 10x minus 2 times 5x minus 2 equals 4. I bring down my 10x, distribute my -2, which is -10x plus 4 should equal 4. My 10x's cancel, and 4 equals 4. The system is dependent, and the solution is all the points on the line. Using substitution and elimination to solve systems. Substitution is the easiest method to use when you have the setup of y equals or x equals. Also, substitution can be used easily if one of the equations has a 1y or a 1x. Elimination is the easiest to use when we have the same number but different signs in front of our x or in front of our y. If we don't, we can use elimination by multiplying each equation by a number that will allow us to have the same number but different signs in front of our x or in front of our y. Solving inconsistent and dependent systems. An inconsistent system results in a false statement because they are parallel lines and they don't cross. My solution is an empty set. Dependent systems result in a true statement where we have the same line and the solution is all the points on the line. For both inconsistent and dependent systems, your x and your y will both cancel out to 0, and we're just left with our constants. Since a dependent system is the same line, then the constants will be the same. Since inconsistent systems are parallel lines, those constants will be different.